Hey, good evening everybody. Welcome to day 4 for Sprint 12th grade board exams. For newcomers, this is Bhavdeep Sir. I'm a happy and proud master teacher here. I love kids, I love physics and love teaching physics to kids. So welcome everybody to day number 4. Today we are going to cover magnetism. Today is 31st of January. We are going to cover magnetism today. So if you have not seen the previous sessions, please go back and see those. They were awesome. So let's make sure that everybody subscribes to the channel, and also more important is to share with your friends, relatives, classmates, neighbors, so that everybody can get free education here. So make sure you subscribe and also share. Press the bell icon also so that you can get the notifications about any future, and we have a lot of awesome courses coming up. You're going to be notified for that. So as always, the strategy is to make things simple here. The derivations, numericals, calculations, whatever you thought were like jalebi kind of thing, it's going to be simplified here. So we are going to make sure we go by simplicity here. We are going to do all the questions, all the derivations a simple way. Obviously this is a short-term course, so I'm not going to do all the derivations, but whatever we do today, you're going to get an idea about how you can simplify things. First, why are we talking about board exams? And I have said this in past 3 days also. Board exams are very important because if you're thinking of IITs or NITs or centrally funded institutes, you have to score 75% marks or 20 percentile in your board exam. Secondly, if you're thinking about NEET exam, you need 50% marks in physics, chemistry and biology. So board exams are very important here. But more important than that is clear the concepts. We are here to learn physics. We are not here just to score marks, get percentiles, ranks and all that. Physics is going to help you long run, long way in your life, in your career, everywhere. So in order to understand physics, you have to clear your concepts. Board exams, the best part, as I said earlier also, you have to study the derivations, subjective questions and all that. So you really go into the insights of many things that you do not go into the competitive exam world. So make sure you give enough importance to these board exams to clarify your concept. So let's get started with aaj ka agenda. Day number 4 is all about magnetism today. Magnetism. कितने मार्क का आएगा? 8 नंबर का. ये plus the other chapter we are going to cover that. ठीक है? तो marking scheme has to be completely understood, has to be. You have to really think, because the electromagnetic radiations 3 number का आता है, लेकिन it's a really scoring kind of thing. So make sure marking scheme is completely understood by you. So from point of view of study strategy, all the derivations from the NCERT books have to be completely done and in the simplified way. मुश्किल वाला नहीं करना, simplified way. NCERT book is the best book. That's the one book if you have to study, that's NCERT. बाकी की books बाद में आती है. तो all the back exercises have to be completely done yourself. No ready-made solutions. If you're able to do them yourself, you're going to rock the exam. Every question, including the additional exercises. Past year question papers, I've said in the past also, 5 साल के तो जरूरी है. उससे ज़्यादा करने हैं तो कर लो. कम से कम 5 साल के. Look at the questions, try to make the strategy, try to write down the answers and then compare that to the marking scheme, because marking scheme tells you what the CBSE board is expecting or what your board is expecting. Vedantu has lot of the stuff over there. If you go to vedantu.com, you can get all the past year question papers with the solutions. I would recommend first do those questions without looking at the solutions, uske baad solutions dekhna. Pehla question, I'll just move out here and let you read the question. In what way is the behavior of diamagnetic material different from that of a paramagnetic? अभी diamagnetic, paramagnetic कई बार confusion हो जाता है क्या यार, है ना? पढ़ा होना चाहिए अभी तक तो, but if you're not read it, diamagnetic क्या होता है? Diamagnetic में every atom, I will not go into those details because time is limited, every atom has no magnetic moment. सारे जो electrons का spinning moment था वो सारा cancel out हो गया. तो diamagnetic material has no atom level पे भी कुछ नहीं होता, है ना? और paramagnetic में क्या होता है? Every atom has some moment, but that cancels out. इस atom का इधर, इस atom का इधर, इस atom का इधर, इस atom का इधर. All these are randomly oriented. See the difference again. In diamagnetic materials, every atom has zero magnetic moment. In paramagnetic, every atom does not have, atom level पे सबके पास मोमेंट है, एक का इधर, एक का इधर, एक का इधर, everybody crosses out. फेरोमैग्नेटिक में क्या होगा, डोमेन्स हो जाएंगे, एक डोमेन में सारे इधर अलाइंड है, दूसरे में इधर अलाइंड है, तीसरे में इधर अलाइंड है. फेरोमैग्नेटिक और आयरन, कोबाल्ट एंड निकल, क्योंकि वो ऐसे डोमेन होते हैं, रीड दैट अगेन फ्रॉम योर बुक, बिकॉज दे आर अरेंज लाइक दिस, व्हेन यू अप्लाई अ मैग्नेटिक फील्ड वो सारे डोमेन्स एक डायरेक्शन में हो जाएंगे, स्ट्रॉन्ग मैग्नेट बन जाएगी. पैरामैग्नेटिक में somebody was aligned here, somebody was aligned here, somebody was aligned here. When you apply the magnetic field, they all get aligned in the direction of magnetic field. In diamagnet, because there was no magnetic moment, atoms को जब इलेक्ट्रिक मैग्नेटिक फील्ड इधर दोगे, उसका मैग्नेटिक मोमेंट इस डायरेक्शन में आ जाएगा. अगेन आई एम गोइंग टू रिपीट दैट बिकॉज द क्वेश्चन टॉक्स अबाउट पैरामैग्नेटिक एंड डायमैग्नेटिक. Diamagnetic did not have any magnetic moment at the atom level. So let's say there is a magnetic field in this direction. All the atoms will actually, not all the atoms, but whatever want to align, they will align opposite to that. उल्टा मैग्नेटिक फील्ड बना देंगे, वो अपोज करेंगे उसको. डायमैग्नेटिक में, पैरामैग्नेटिक में ऑलरेडी थे, वो अलाइन इन दैट डायरेक्शन हो जाएंगे. सो लेट्स सी द पिक्चर्स एंड ट्राई टू अंडरस्टैंड दैट. So this is an example of diamagnetic. To start with, there was no magnetic moment. When you apply the magnetic field upper, they align themselves downward. So they align opposite to that. They are making a magnetic field opposite to that. और जब हटा दिया तो खत्म हो गया. Now look at the paramagnetic and try to compare that. Paramagnetic already had, but they were aligned in a random fashion. When you apply a magnetic field upwards, they align upwards. They align in the direction, these align opposite. That's the only difference. और जब हटा दिया, then it goes back to its normal behavior. Okay? So now this is what you can, as I always say, this is a sample answer. You're not supposed to memorize these. You're supposed to understand what I'm teaching here and whatever the books teach and your teachers teach, and then frame the answers yourself. Again, that thing there, kahan gaya? Yeah, this thing tells you this is a simple question. It's a very simple question. Read the question, I'll give you enough time for that. Proton and electron traveling along path enter region of uniform magnetic field. है ना, read the question here. Looks के भाई क्या हो क्या रहा है, कैसे, कौन सा फॉर्मूला यूज करना है, कुछ नहीं यूज करना, वेरी वेरी सिंपल. पहले तो समझो होगा क्या यहाँ पे. There is a charge moving one way. There is a field perpendicular to that. It's going to experience force. है ना, ये हमने सबने पढ़ा हुआ है. So let's assume there is a proton going this way, मतलब current going this way. Let's say there is a field going this way. है ना, मेरे हाथ को देखो. Proton going this way means current going this way, field going towards you, so there's a force going up. That's it. है ना, right hand thumb rule. और लेफ्ट हैंड थंब रूल, सॉरी लेफ्ट हैंड यूज कर लिया इसमें. लेफ्ट हैंड थंब रूल टेल्स मी इफ द प्रोटॉन वाज गोइंग दिस वे, देयर इज अ फोर्स दिस वे 90 डिग्रीज टू द मोशन. अ फोर्स 90 डिग्रीज टू द मोशन इज अ सेंट्रीपेटल फोर्स. तो ये इसको इधर मोड़ेगा एंड इट इज गोइंग टू गो इन अ सर्कुलर पाथ. नाउ सिंपल थिंग है ना. सेम गोज विद इलेक्ट्रॉन में उल्टा हो जाएगा, बिकॉज इलेक्ट्रॉन इज गोइंग दिस वे, आई विल से करंट गोज दिस वे एंड इट गोज दिस वे. द ओनली डिफरेंस इज बोथ ऑफ एंटर लाइक दिस. Proton goes this way, electron goes this way. We are not interested in the direction, we're talking about the frequency here. लगता है बहुत मुश्किल क्वेश्चन है. I'm going to simplify this for you. सबसे पहले सोचो कि फोर्स कहाँ से आया. फोर्स इज कमिंग फ्रॉम दैट इलेक्ट्रिक फील्ड, मैग्नेटिक फील्ड, राइट. मैग्नेटिक फील्ड से कितना फोर्स आएगा? चार्ज मल्टीप्लाइड बाय द मैग्नेटिक फील्ड multiplied by velocity. This is the force that the proton or electron experience. Now this force is acting as a centripetal force. Centripetal force क्या होता है? Mass times omega square, और omega square नहीं लिखता क्योंकि velocity है. एक बार और इसको कर देता हूँ, because see, if I start with omega, many students will get confused. So let's start with, there was a magnetic field, there was a charge, and there was a velocity here. So let's write in terms of velocity, because velocity will cross out and then we can convert to omega later on. This is equal to mass times velocity square by the radius of the path. वो जो path, circular path था. यहाँ तक clear है. अब एक तो velocity कट गई यहाँ पर. Now I'm still not done, because they're talking about frequency. I just not got something there. Yeah, that's still not done. Now think about rearranging all this. रीअरेंज करके वेलोसिटी क्या हो जाएगी, वेलोसिटी इज मोर अबाउट फ्रीक्वेंसी एंड ऑल दैट, राइट, इजंट इट? सो वो फ्रीक्वेंसी हो गई। तो ना फ्रीक्वेंसी हमको पता करनी है, तो कैसे करें? b टाइम्स q इज इक्वल टू मास। अब फ्रीक्वेंसी, वेलोसिटी और फ्रीक्वेंसी में क्या रिलेशन, लेट्स थिंक अबाउट इट। वेलोसिटी इज द डिस्टेंस ट्रेवल्ड डिवाइडेड बाय द टाइम, है ना? उसको हम ऐसे लिख सकते हैं, या उसकी जगह मैं सिंपल ऐसे इसको ओमेगा आर कर देता हूँ, वो ज़्यादा सिंपल हो जाएगा, बिकॉज देन यू हैव टू क्रॉस इट आउट। ओमेगा आर से क्या फायदा हो गया, आर कट गया, ओमेगा आ गई एंगुलर फ्रीक्वेंसी। एंगुलर फ्रीक्वेंसी से भी काम चल जाएगा। इफ यू वांट टू सी रियली फ्रीक्वेंसी देन यू कैन राइट इट एज 2π5, वो भी कर सकते हो। बट मेन थिंग इज यू आर गेटिंग फ्रीक्वेंसीज इनवर्सली प्रोपोर्शनल टू द मास, सो यू कैन राइट इट एज BQ by m is equal to omega, आ गया आंसर। But many students get confused with angular frequency. If you want, you can write it like this also, because omega is 2πf. अब फ्रीक्वेंसी और मास आर इनवर्सली प्रोपोर्शनल, जिसका मास कम उसकी हाई फ्रीक्वेंसी, किसका मास कम है, दो चीजें हैं, प्रोटॉन्स एंड इलेक्ट्रॉन्स। इलेक्ट्रॉन का ऑब्वियसली मास कम है, and that is why it has a higher frequency. That is all. So let me show you how you can present it in your exams here. एग्जाम में ये सारा लिखना है ना, एग्जाम में तो ये सारा लिखना पड़ेगा, यू हैव टू एक्सप्लेन इट, बट यू डोंट हैव टू रट्टाफाई एनीथिंग। द वे आई डिराइव्ड इट इन 3 लाइन्स, यू कैन डिराइव दैट इन योर रफ सेक्शन, और ये अपने दिमाग में करो, एंड देन यू कैन प्रेजेंट इट लाइक दिस। सबसे पहले तो दिमाग में करो, फिर रफ सेक्शन में स्केच स्क्रिबल कर दो उसको, है ना, एंड देन यू प्रेजेंट इट इन अ नीट फैशन। यहाँ पे क्रॉसिंग थोड़ा कम करो। ओके, नेक्स्ट क्वेश्चन, आई मूव आउट हियर। Using Ampere's circuital law, है ना, obtain an expression for magnetic field due to infinitely long straight current carrying wire. We did this kind of scenario yesterday, or day before yesterday, when there was an infinite sheet, and I said infinite sheet doesn't matter, a galaxy long sheet. This is a sheet of some metal here. If you're looking at a point here, it looks like choti si, but if you come closer to that and you start looking in all the direction, it looks like a huge one. So similarly it says infinite. Infinite का मतलब ये नहीं कि यहाँ से लेके पता नहीं कौन सी गैलेक्सी तक चले गए। Infinite means wire के पास, है ना? But in order to understand it, we are going to make a point a little further away. You are supposed to find the magnetic field. अब क्या करना है, Ampere's law लगाना है। So इसमें क्या करो, एक तो वायर बना दी, है ना, वायर पे करंट जा रहा है, आए कोई पॉइंट ले लिया, है ना, इस पॉइंट पे मैग्नेटिक फील्ड पता करना है एम्पियर्स लॉ यूज करके। पहले तो एम्पियर्स लूप बनाओ, लाइक गॉसियन सरफेस, यू लुक फॉर सिमेट्री, यू लुक फॉर सिमेट्री इन दिस केस, you have to look for symmetry and say okay, I have to find the locus of all the points which will have the same magnetic field. अब ये वायर है, इसके इधर मुझे मैग्नेटिक फील्ड पता करना है, बट डायरेक्शन भूल जाओ तो मैग्नीट्यूड वाइज अगर उसके अराउंड मैं एक सर्कल बना दूं, ये ले लिया मैंने अपना कड़ा, so think about it, this was the wire, all the points on this circular loop is going to have equal magnetic field, isn't it? So that's exactly what I'm going to do now. So I'm going to draw a circle here, है ना, let's say the distance was r, so I'm going to make a circle of r here. R is the radius of the circle, and then use the Ampere's loop. So it says B dot dl, उसका integration is equal to mu naught times the current enclosed, है ना, current enclosed is what matters. आसपास में कोई wire है, doesn't really matter to you. Now B dot dl, B is same, that is the point that we take the symmetry there, because B is same in all of them, the magnitude of B, and that is why you can take it out of the integration sign. Now integration of dl क्या है? I take this tiny thing here, let me show you here, ये है ना, dl क्या होता है, यहाँ पे ठीक दिख रहा, हाँ, तो यहाँ पे एक छोटा सा पॉइंट ले लिया, फिर छोटा सा पॉइंट ले लिया, छोटा सा पॉइंट ले लिया, इंटीग्रेट कर दिया, तो यार इंटीग्रेटिंग यहां से यहां तक ये dl है, प्लस ये dl प्लस ये dl, दैट इज 2πr। तो क्या आ गया मेरे लेफ्ट साइड में, b टाइम्स 2πr इज इक्वल टू म्यू नॉट टाइम्स i। बस उसको नीचे ले जाओ, मैग्नेटिक फील्ड इज म्यू नॉट i बाय 2πr। ये हमने दिमाग में बना लिया, स्केच बना लिया, रफ में कर लिया, और उसके बाद इसको प्रेजेंट करना है, तो piece of cake. Again and again I'm repeating the same thing. Do not start writing the final answer. First make a plan in your mind, okay, what is the approach, what is the concept I'm going to use here, and then maybe you can do it in the rough section of your answer sheet, and then finally write all this. Simple सा, देखने में लगता है इतना बड़ा सा है. It's going to give you full marks. कितने marks का था? It's 3 mark question. Let's move on. Again, that thing tells you, okay, it's a simple question, another simple question. Take a look at it. Using the concept of force between two infinitely long parallel current carrying conductors, define 1 ampere of current. It's going to use the same concept we derived in the previous question. 2 वायर है, 2 पैरेलल वायर, एक वायर बना दी है ना. पहले ये दिमाग में सोच रहे हो तुम, एंड देन यू मेकिंग इट इन रफ. एक वायर बना दी, इसमें करंट बना दिया. बिकॉज ऑफ दिस करंट देयर इज अ मैग्नेटिक फील्ड समवेयर हियर. तो ये पॉइंट पे कोई मैग्नेटिक फील्ड आ गया. अब इस पॉइंट पे कोई मैग्नेटिक फील्ड आ गया, देन इफ आई पुट अनदर वायर हियर कैरिंग करंट I2. नाउ थिंक फ्रॉम सेकेंड वायर्स परस्पेक्टिव. It is a current carrying wire in a magnetic field. This magnetic field is produced by this, है ना. पहले ये वायर थी, this is producing a magnetic field. This magnetic field already existed and I bring in another wire and put with a current of I2. This is going to experience some force. How much force? Magnetic field times the current times the length of the wire. So let's start doing the question. Let's start actually thinking about the approach. करना क्या है. फोर्स यहां पे कितना होगा? फोर्स एक्सपीरियंस बाय दिस वायर इज इक्वल टू द मैग्नेटिक फील्ड मल्टीप्लाइड बाय द करंट मल्टीप्लाइड बाय द लेंथ. अब मैग्नेटिक फील्ड तो हमने पिछले डेरिवेशन में किया था. तो मैग्नेटिक फील्ड हियर इज बिकॉज ऑफ दिस. हाउ मच इज इट? इट इज म्यू नॉट टाइम्स I1 डिवाइडेड बाय 2 पाई r, है ना. वेयर r इज द डिस्टेंस बिटवीन देम. r की जगह d ले लो, जो लेना है ले लो. ये हो गया, ये मैग्नेटिक फील्ड है. करंट कितना इस वायर में? I2 टाइम्स ऑफ लेंथ ऑफ द वायर. दिस इज अ फोर्स. तो ये तो मैंने डिराइव कर दिया. व्हाट्स द फोर्स बिटवीन 2 वायर्स. ये डेरिवेशन भी एग्जाम में आ सकता है, तो आई हैव डन दैट फॉर यू आल्सो. ठीक है, कितना सिंपल है यार, सिंपल है. इसको प्रेजेंट करना इन मोर नंबर ऑफ स्टेप्स, बट लुक एट इट, 2 लाइन है ना. एज आई सेड, सिंप्लीफिकेशन. चलो अब ये देखो इसमें, अब इसको डिफाइन क्या करना है. व्हाट इज 1 एम्पियर ऑफ करंट? सो यू कैन स्टार्ट सेइंग, okay, 1 ampere of current is such a current that if it flows in 2 wires at a distance of 1 meters, है ना. ये कर लो इसको. अगर ये डिस्टेंस जो है इसको मैं 1 मीटर कर दूं, इस लेंथ को भी मैं 1 मीटर कर दूं, करंट को 1 एम्पियर कर दूं, तो फोर्स कितना आ जाएगा? म्यू नॉट बाय 2 पाई. म्यू नॉट कितना होता है? म्यू नॉट इज 4 पाई टाइम्स 10 to the power -7. ये म्यू नॉट होता है. म्यू नॉट बाय 2 पाई कितना हो गया? डिवाइड बाय 2 पाई कर दिया. कुछ मेमोराइज नहीं करना. दैट्स द रीजन आई एम डूइंग ऑल दिस. यू डोंट हैव टू मेमोराइज एनीथिंग. इट गोज बाय सिंपल लॉजिक. सो म्यू नॉट बाय 2 पाई इज 2 times 10 to the power -7. अब देखो, अब now we are going to frame it. We are going to say 1 ampere of current is such a current that if you make it flow in 2 wires separated by 1 meter of distance, the force experienced per meter of the wire is going to be this many newtons. क्योंकि सब कुछ अगर SI यूनिट्स में है तो ये भी SI यूनिट्स. डन हो गया. इसको देख लेते हैं एग्जाम में कैसे प्रेजेंट कर सकते हैं. Looks, I'll move out here. And you can see that जो हमने किया था, we devised the strategy. This is what we are going to do. Now you are going to write it. सारे steps लिखने हैं. Finally, force is this much. That is 1 ampere of current. अब ये देखो, the question आ गया है current electricity से, but that's fine, because this is here on purpose. This is here to show you थोड़ा सा इधर उधर से भी करना है. तो let's do this question for fun. So emitter and a milliammeter are converted from a galvanometer. Out of the two, which current measuring instrument has a higher resistance? This question actually I was planning to do in current electricity yesterday, but I forgot to do that. तो मुझे याद आया, मैंने बाद में ऐड कर दिया था इसको. ठीक है, थोड़ा सा फन भी हो जाता है, थोड़ा ब्रेक भी हो जाता है, and then you should be prepared for any topic anyways. तो क्या है, what is galvanometer and why are we connecting the resistance? First of all, think about what is galvanometer. Galvanometer is a very highly sensitive device. थोड़ा सा micro amperes of current and all that. Now let's say I take a galvanometer here. Let me make a picture. Let's say I take a galvanometer and I connect it to such a circuit कि ज़्यादा current measure करना, उसमें problem हो जाएगी, क्योंकि the problem is going to be if I do this with a high current, let's say. Galvanometer wire is going to burn. It cannot tolerate that much of current. So I can use it to find microamperes of current, very sensitive device. But if you try to find more current with that, it's going to burn. Solution. Solution is you take this resistance, a very low resistance, which we call a shunt. Okay, it's called shunt. Now what will happen? Electrons are coming here, the charges are coming here. Because this is low, most of the charges will go through that. Some charges will go through that. So now if you know this is 99 times of this and all that, we can do calculations. Agar in 99 times iska resistance hai, 99 times of the charges will go there. So whatever this is measuring, I can calibrate all that and I can see okay itna. Abhi shunt kyun lagaya? Because there was a lot of current going through this. Now if I have to measure milliamperes of current, think about that way. If I have to measure milliamperes of current, I don't want lot of current to go through there anyways, right? But if I have to measure amperes of current, I want lot of current to go there. If I want amperes of current, lot of current has to go there, means this has to be less. So let's write down what we found just now. For emitter, it's going to be lot of current going through this, so this S has to be less. For milliampere kind of things, I need shunt which has to be more, because I don't really care. And I care utna care nahi, because the point is if it is so less, then everything will go there. Okay? So let's see how you can frame this answer in your exam. एक number का question है. Higher is the range, the lower is the value of shunt. As I said, if you want to measure amperes of current, you need a smaller shunt. That's हाँ भाई, अगेन वन ऑफ द क्वेश्चंस कि डेरिवेशन आ गया, क्या करें इसका, आयरन रिंग ऑफ रिलेटिव है ना, टोरॉइड आ गया, टोरॉइड तो किया ही नहीं था, बट करना ही कुछ नहीं है इसमें, तो एम्पियर्स लूप लगाना है, वो लोगो वहाँ बना हुआ है, दैट शोज इट्स अ वेरी सिंपल क्वेश्चन. वेयर एवर यू सी दिस लोगो थ्रू आउट द कोर्स, इट मीन्स इट्स अ सिंपल क्वेश्चन, लुक्स डिफिकल्ट. 3 मार्क का क्वेश्चन है. तो लेट्स डू दिस. पहला पार्ट टोरॉइड ले लिया है ना. अब टोरॉइड में मैं इसको थोड़ा सा ज़्यादा बता रहा हूँ, जितना क्वेश्चन में पूछा उससे ज़्यादा. सपोज आई वांट टू फाइंड द इलेक्ट्रिक फील्ड हियर, सॉरी मैग्नेटिक फील्ड हियर. मैग्नेटिक फील्ड कैसे, एम्पियर्स लूप बी. सो फर्स्ट ऑफ ऑल आई एम गोइंग टू ड्रॉ एम्पियर लूप हियर. सो बी डॉट डी एल, जो भी है लेफ्ट में, डजंट मैटर, इज इक्वल टू म्यू नॉट टाइम्स द नेट करंट. नेट करंट तो जीरो है, बिकॉज लुक एट द टोरॉइड, सम करंट इज गोइंग अप, some current is going back. So it's more like अगर मेरा loop है, current going up, current going down, current going up, current going down. So if there are 1000 loops, 1000 times current goes up, 1000 times current goes down. So there is no current at all. So there is no magnetic field here. By the same logic, अगर मैं यहाँ पे amperes loop बना दूँ, उसके अंदर तो कुछ है ही नहीं. So there is no magnetic field here, there is no magnetic field here. Magnetic field 0 here, magnetic field 0 here, period. We are interested in this blue thingy. So some point here, let me draw that for you, and you will see how easy it is. This is all the rough work we are doing, and we'll see the final work on the next slide. ये हम devise कर रहे हैं strategy, what we have to write there. So यहाँ पे look at this, magnetic field in the ring. I have to find magnetic field here, let's say. So what I do is, first of all, I draw Ampere's loop. Ampere's loop is going to be symmetric loop. Whatever is the magnetic field here is the magnetic field here is the magnetic field here. Because they are all same, they are symmetric except for the direction there. Then you start writing the Ampere's loop. Okay? So B dot dl and then integration of that. That is supposed to be equal to mu naught times the current enclosed. You can write it enclosed. अभी तो formula लिखा है मैंने. अब इसमें B is same, so I can bring it out of integration. Integration of DL, the same thing that we did, है ना? DL plus DL plus DL, that is 2 pi r. That is 2 pi r. So let's write it as 2 pi r. B dot 2 pi r is equal to mu naught current enclosed. एक वायर में करंट आए है. कितनी वायर है? Let's say there are n loops per unit length, है ना? Small n, छोटा वाला n. n loops, n of these loops per unit length. कितनी length है? 2 pi r length है. Again I'm repeating that. If there are n number of loops per unit length, the length here is 2 pi r. So I enclosed कितना हो जाएगा? तो I जितना है, एक वायर में इतना है, कितने I हो गए? n times of 2 pi r. Because n, this छोटा n represents number of loops per meter. अब ये 2 pi r कट गया यार. तो ये सिंपल सा एक्सप्रेशन आ गया, B इक्वल्स टू म्यू नॉट n टाइम्स I. रट्टा मारने की जरूरत ही नहीं है, तुम तो वैसे ही डिराइव कर लोगे. 2 मिनट से ज़्यादा नहीं लग रहा है इसमें. 2 मिनट क्या, मैं तो कह रहा हूँ 20 सेकंड से ज़्यादा नहीं लगने. आई वॉज एक्सप्लेनिंग दिस, दैट्स व्हाई, राइट? तो लेट्स सी हाउ यू कैन प्रेजेंट दिस इन द एग्जाम नाउ. In the exam, you got to write all of this, right? And also you can add at the end. We were thinking about like vacuum when you said mu naught. But if there is something core over there, that core has some permeability, you can add mu r to that. That is really important. Susceptibilities. That was part 2 of the same question. Now susceptibility. Susceptibility क्या होती है? Xi. Xi is all about how much of magnetization is done in a material because of the external magnetic field. Up, look at that number. That's a tiny little number there. Now, but it is positive. Remember, we did it in the first question itself. Magnetic field here, paramagnetic will have the magnetic field induced inside of it in the same direction, but tiny little amount. तो ये टाइनी लिटिल अमाउंट इन द सेम डायरेक्शन है, तो पैरामैग्नेटिक है. अगर डायमैग्नेटिक होता तो फील्ड इधर, मैग्नेटिज्म इधर, ये नेगेटिव नंबर होना था. ससेप्टेबिलिटी इतना सा दिया है, ससेप्टेबिलिटी इतना सा दिया है, ये तो पैरामैग्नेटिक है. खत्म, ये आंसर. ठीक है, देन आई विल शो यू हाउ यू कैन राइट इट इन द एग्जाम. लुक एट दिस. It's a paramagnetic material which is weakly attracted by the magnetic field. तो magnetic field उसके अंदर है. simple. Let's go through the next question. Biot-Savart Law. Biot-Savart Law क्या है यार? This you might have already done that. So I'm going to show you. Yeah, I'll show you the printed version of that. Now two identical. Let's focus on this and make the strategy for this. Two identical circular coils, P and Q, each of radius R, है ना? वो रखे, एक इधर रखा है, एक इधर रखा है. तो कैसे होगा? जैसे ये है, एक रिंग है इधर, मैग्नेटिक फील्ड इज दिस वे. सिमिलरली एक ऐसे रख दिया तो मैग्नेटिक फील्ड इज दिस वे. सो यू कैन सी वन फील्ड हियर, वन फील्ड हियर, 90 डिग्रीज. पाइथागोरस थ्योरम. इसमें कुछ कॉम्प्लिकेशन नहीं है. देखने में लगता है इतना सारा क्या करना है. परपेंडिकुलर. If this is perpendicular, the fields are perpendicular and they are going to be added like Pythagoras theorem, using Pythagoras theorem. So let's go through the solution here. Now Biot-Savart law is basically, you've seen that it's directly proportional to the current element there, right? That's, you're supposed to write all these steps in the exam. You're not supposed to just write the Biot-Savart law. You're supposed to write this is directly proportional, and we know it is also directly proportional to sine of the angle there. If that angle was 0, that means if you have a wire and you're looking at a point in the line of the wire, you're not going to have any magnetic field in there. It's directly proportional to sine of theta, and then it's also inversely proportional to the square of the distance you're looking at. You combine all three of them, that is all. इसमें रट्टा किसी में नहीं मारना है. I'll move out here so that you can see that. And again, the other thing I was talking about was the ring. So one has a field going up, one has a field going this way. So you add them using Pythagoras theorem. I'm just going to show you the calculations here. It's a piece of cake now. Now look at the number of marks awarded for this. You're supposed to write all the details. 3-mark question. And I show all the steps. 1-mark question may you can quickly scribble and find the answers, but for these questions you are supposed to write all these steps. Now with that said, I'm going to see you tomorrow, same time. Do not forget to share this link. Spread the free knowledge here. We have a lot of new courses coming up. Make sure you subscribe to the channel, press the bell button so that you can get notifications about that. Also download and install the app that we have launched. You're going to get all this PDF in that app, so make use of that. I'll see you tomorrow, same time. Until then, bye bye and have a happy night. So past cannot be changed. The future is yet in your power. Make use of the power here. Bye bye. Good night.